From last week, you should be familiar with the basic anatomy of a wave. You can point to crests and troughs, and you can distinguish between transverse and longitudinal waves. But we now need to learn about the other wave features so that we can better understand them. Today, I'm going to be telling you about two of those features, specifically how they manifest in sound waves, and then I'm going to leave you with the first real piece to our why do different instruments sound differently puzzle. The first element we're going to talk about is wavelength. As the name suggests, it measures the length of a wave. In terms of sound, shorter wavelengths lead to high-pitched sounds, and longer wavelengths lead to low-pitched sounds. I'll show you a concrete example in a moment, but in general, your intuition is going to be good here. If you think of a short wavelength, it's like a small instrument. It's going to have a high-pitched sound. And if you think of a long wavelength, it's like a large instrument, which is going to make a low-pitched sound. But to really show you why this happens, I'm going to use my cavaquinho here to show you what's going on.
By pressing on the string, you effectively make the length of the string shorter, which makes the sound waves it produces have a shorter wavelength as well. The shorter you make the string, the higher pitched it gets. Some interesting math here: if I press the string in such a place as to cut the string in half, the pitch goes up exactly 1 octave. In fact, all the notes in the classical Western tuning system can be produced by making whole number fractional cuts along a string. We'll get to that eventually.
Okay, so there are a couple more things I want to show you, but none of the instruments I have are suited to really getting that idea across. So I have a program here that's going to show you this connection between features of waves and pitch. So if I... Wait, you're not going to be able to see that. Here, let me get you a closer look.
In this program, I can generate pure tones. They sound pure because, as we can see, they are the purest form of a wave, a perfect sine wave, which means I can change the nature of the wave and you can hear what that sounds like. Here I have two sine waves. The only difference between them is their wavelength. The one on the bottom has a smaller wavelength since the crests are closer together, and as we would expect, smaller wavelength means a higher pitch. There's something else I can do to change this wave. Starting with two identical waves, I'm going to take the bottom wave and amplify it, raising the wave's amplitude. If I zoom in farther, you can see exactly what amplitude is. Amplitude is the length of the tallest one of these lines, drawn from the middle section to the top of a crest. In the realm of sound waves, amplitude affects the sound's volume.
Okay, I have one more thing I want to show you, and it uses another super fancy Mr. Gailey science apparatus, namely this lamp and a rope that is tied to it. So I'm going to take this rope and I'm going to waggle it around to form waves. And I want you to watch carefully because something interesting but subtle is going to happen. Let's check it out.
Okay, let's go back for a second look, but in slow motion this time. At first, you only see a single peak on this wave. You could measure its wavelength and amplitude if you wanted. But as I waggle the wave faster, at first it's turbulent, but then it locks into place with this stable motion. Now there are two peaks, and it's clear that the wavelength just got cut in half. If I go faster, the same thing occurs. This time, 3 peaks, and a wavelength 1/3 of the original.
So unlike with my cavaquinho, where I essentially had to shorten the length of the string to change its wavelength, I was able to change the wavelength on this fixed length string. And I want you to think about the implications here, specifically keeping in mind what are the connections between wavelength and pitch. This is, after all, our very first clue that is going to lead us to solve our mystery. So, this week we master all the parts of a wave. Next week, we get into the physics.